Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on trig values of special angles. So before we get started with any of these, I need to talk about the unit circle. Also, by the way, wanted to give a shout out to the Chatta family for requesting this video. Thank you very much for watching, and thanks for commenting. So I'm going to switch over here to the unit circle chart. This is like the absolute necessary component of learning the unit circle. You need one of these charts. You probably should make one yourself. After referencing it for a while, being able to create it yourself is very important. So there's a lot going on here, and I'm going to kind of break down the basics of this unit circle chart. So first off, we got 0 degrees, 30, 45, 60, and it goes all the way up through 360, okay? You see that in degrees, but then you also see it in terms of radians. So degrees and radians are two different ways of measuring the angle in the unit circle, or any angle really. And you can see that 360 is equivalent to 2 pi, and then pi is equivalent to 180, and then you see all the other breakdowns around the circumference of the circle. And the reason why you see that 2 pi, because that is the circumference of a circle. Circumference equals 2 pi r. So that's where that 2 pi comes from. And just in a simple term, there's a better definition, better proof of that. But I just wanted to kind of glaze over it for this video. And then you'll notice that the second thing you'll notice is we have these values here that look like x and y coordinates. And I'm just going to talk about one and then apply it to the rest. So you see right here, we have, this is a 30-degree angle, and then we have these values for x and y. You're probably wondering, what is that about? So if we were to extend this line down, you can see that we've created a triangle. Let me show you that in red, just so it's a little more clear. So we have a triangle, and it's a right triangle. And then this vertical side right here, let me make that in a different color. I'm going to make it in this, maybe this dark blue. So this blue side right here, that corresponds to the y coordinate, okay? Right here. That corresponds to the y coordinate. And this value is the opposite side. Okay, I'm going to continue on. Let me go to orange here. So this orange side, this is at the bottom. This corresponds to the x coordinate, right? So it reaches out, and then this value right here, that would be the x coordinate, and that's the adjacent side. So let me go ahead and change this x to be orange. So that's the adjacent side. Now, why is that important? Well, it's important because in this Khan Academy video, it's only sine and cosine we're talking about, so that kind of makes it a little bit easier to talk about. If we're talking about the sine and cosine of values, we're talking about the opposite over the hypotenuse for sine, or the adjacent over the hypotenuse for cosine. So our x value, okay, that corresponds with our cosine, because that's the adjacent side over the hypotenuse, the ratio of the adjacent side over the hypotenuse. And our y value, that corresponds to our sine value, okay? So I'm going to go ahead and change that to blue, just so you're aware that the sine kind of goes with the y, and the cosine goes with the x. Okay, so in simpler terms, if we were to take the sine, let me change it to purple actually. If we were to take the sine of, and this is the reference angle, I'll be saying that a lot, of this reference angle, sine of 30 degrees, that is going to be 1/2, because it's the ratio of the opposite side to the hypotenuse. And the hypotenuse is the same for all of these. The hypotenuse is going to be that length right there, and you can see that's just the radius of the circle, thus the unit circle, and all those measurements are just 1. So it's the same, but the angle is going to change the ratio of this opposite and adjacent side. As you can see here, if we bump up to 60 degrees, okay, you can see that this opposite side is going to get much larger. Okay, so this opposite side becomes longer, and then this adjacent side, the x value, is become smaller. Okay, and that's just how it works. As you change this angle measurement, it just changes the values, the ratios of these sine and cosine measures, okay? And then just looking at 45 degrees, one thing you'll know about 45 degrees, it's splitting halfway between 0 and 90. So our y value and our x value are going to be the same. That's why you see the sine and cosine are exactly the same for 45 degrees. And then you'll see patterns here, okay? So for 30, 45, and 60, you'll notice that these values repeat constantly. And another thing that I like about this chart is you'll notice that in blue, they all have the same x and y. That's because it's a 30-degree reference angle, okay? These are all corresponding to a 30-degree, and you'll see that because it has that pi over 6 for radians. Okay, and then in purple, you'll notice that these are the 45-degree reference angles. Okay, so 45-degree reference angles, and you'll see that it has pi over 4 for the radians, and you'll notice that the sine and cosine are all the same, just with a slight variation, which I'm going to talk about in just a second. And then for 60-degree, you'll see the same thing happening, okay? Now, the last puzzle piece here is some of these values are negative and some of them are positive. So in the green, I'm going to erase all this. And by the way, if you don't need all this and you just want to get the Khan Academy, I hope you would have skipped ahead by now. I'm going to leave some chapter markers later on. But yeah, you can skip ahead. So in green here, both sine and cosine are positive. So in this section, sine and cosine are both positive. That's the first quadrant. And in this section, it's different. So I'm just going to break this down. If we have anything above the y-axis, the sine is going to be positive. Okay, anything above the x-axis, sine is positive, okay? And then anything to the right of the y-axis, okay, these are the positive x values, so this is where the cosine is going to be positive, okay? And then the exact opposite is true for both x and y. So if we're below the x-axis for sine, that's where it's negative, and if we're to the left of the y-axis for cosine, that's where it's negative. And you can see that represented with all these x and y values in this chart. Okay, so if you wanted to do this Khan Academy just by looking at this chart, it's super easy, okay? It's super easy. We just have to look at the value and then find either the x or y value for and translate it into sine or cosine, okay? So let's go back to the Khan Academy. Let's take a look here. We're asked to find cosine of 5 pi over 3 and also the sine of 5 pi over 3. So the first thing I would do is I'd go over here and I'd find 5 pi over 3. You'll notice that it's a 60-degree reference angle, okay? And what I mean by that is there's like 1, 2, 3, 4, 5, okay? You can see that there's 5 60-degree turns before I get to this, okay? So it's the same values of this 60 degrees, but just one wrinkle, and that is the y value is negative. The sine of 60 is going to be, or sorry, this isn't 60. The sine of this one is 300. 5 pi over 3 is going to be negative here. So it's going to be negative because it's below the x-axis, and you can see it's negative 3 over 2. Oops, I put 3. Okay, so we see that our sine is going to be negative square root of 3 over 2. So we can go ahead, whoops. We can go ahead and go negative square root of 3 over 2 for the sine. Let me go ahead and type that in. Square root of 3 over 2 for the sine. And then the cosine was actually positive, right? Because we're in the positive value for the x's. So we're going to just put 1/2 here, and then we should be good. So we got negative square root of 3 over 2. We got positive 1/2, and we got it. Okay, now we're talking about 315. Anytime it ends with a 5, you know it's going to be a 45-degree reference angle, and we can just check that here. Here it is, 315. Why is it a reference angle of 45 degrees? Because we look at the components of 45, and we can see how many turns we have before we get to, let me change it to a brighter color. So we have 145, then we have 2 to take us to 90, 3, 4, 5, 6, 7. And that's where that 7 pi over 4 comes from. It's pi over 4 is 1, so 7 pi over 4 would be 7 of those turns, and that's what takes us to 315. Still applies that the sine is going to be negative and the cosine is going to be positive. 45-degree reference angles are pretty easy because the sine and cosine are the same. So that's something that's nice about 45 degrees, but we have square root of 2 over 2, and then the sine was negative, so we have negative square root of 2 over 2. And I didn't talk about it tremendously in this video, I don't think at all, about why these values are what they are. I will make another video on that actually later this week. So if you want to check that out, wait for unit circles, CUDA worksheet tutorial. I will talk about why these sine and cosine values are what they are. But for this video, I think it's just easier to reference the unit circle. Okay, so we got 5 pi over 4. Let's go ahead and check that out. I know it's over 1 pi, so it should be over here in quadrant 3, and it is. So here we are, and it's 5 turns. It's a 45-degree reference angle. And in this quadrant, I think it's pretty simple, just like the first quadrant, because both sine and cosine are negative. So again, it's a 45-degree reference angle, because we see that it's pi over 4. And both of these are negative, so I'm going to put a negative sign. And then for 45, it's easy because it's square root of 2 over 2. And then square root of 2 over 2 for both the sine and cosine. We'll check it, and we have one more. So cosine of 330. So we are only beneath the x-axis here. 330 is almost a 360. This is a 30-degree reference angle. And the reason why it's 30-degree reference angle, okay, I hope you guys have been catching on, but you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 of those turns, and that's why it's 11 pi over 6, will take us to 330. So it's the same measurements, same trig values as the 30-degree angle, except one difference, that the sine is negative in this quadrant. So I'm going to go ahead and use these values. The sine is negative 1/2, and the cosine is positive square root of 3 over 2. So I have positive square root of 3 over 2 for here, and then negative 1/2 for my sine. And it looks like I'm done with this Khan Academy. And there we go. So I hope this Khan Academy tutorial was helpful. Leave a comment if you need more help on any other Khan Academy or any other math topic in general. Make sure to check out some of the playlists I have, and I look forward to seeing you next time right here on Wes Explains Best.